Okay, guys, move on to chapter 29. Okay, open up the lecture reading material, and then open up lecture 20 lecture notes. So you need the lecture reading material. And then, okay, so just open up the chapter 29 magnetic fields. So that's going to have a bunch of problems. And most importantly, you need to have the lecture notes. All right, so that's what you need.
At Geico Auto Insurance, we handle your claim quickly, so you don't have to bum a ride to work.
So what makes materials magnetic? Iron is very easily magnetizable, so is cobalt, nickel. So why is it that certain materials are very easily magnetizable? Aluminum, not so much. Gold, not so much. So what about iron that makes it so easily magnetizable? All right, at this point, if you have an idea, just jump in. If you don't, we'll just take off. Anybody?
Iron can be polarized, making a magnetic field.
Okay, so Lucas, I'm going to give you 5 points. What do you mean by polarized?
Meaning that all the atoms in the iron, for example, are going to be oriented a certain way, so they're going to be able to flow a magnetic field.
So you're thinking that the magnetic field somehow is related to the orientation of the atoms?
Yes.
Okay, so where'd you get that idea from?
Just from graphics I remember from high school and stuff like that.
Okay, it's not bad. I'm going to give you 5 points for that one as well. All right, some prior background.
Has ever visited. No one has ever seen this place. Yet what happens here affects every one of us, every day of our lives. It's 2,000 miles beneath our feet, the Earth's molten core. Here, a vast ocean of liquid iron generates an invisible force, the Earth's magnetic field. It's what makes our compasses point north, but it does a lot more. It helps to keep the Earth a living planet. Our neighbors, Venus and Mars, have only weak magnetic fields, which means they're unprotected from the deadly radiation sweeping through the solar system. The Earth, on the other hand, exists within a vast magnetic cocoon, a force field that for billions of years has sheltered us on our journey through space. But now, scientists have made a startling discovery. It seems there's a storm brewing deep within the Earth, a storm that is weakening our vital magnetic shield.
The Earth's magnetic field has been our protector for millennia, and now it appears it's about to go away.
The Earth's magnetic field is getting weaker rapidly.
We cannot guarantee that the magnetic field of the Earth is still going to be there 1,000 years from today.
Is our invisible shield about to disappear?
The question is not if that's going to happen, it's when that's going to happen.
Could the Earth really lose its magnetic field? And what will happen if it does?
All right, so I got a bunch of questions for you. Number one, it's about time that somebody wrote a song about magnetism after gravity. Number two, Earth's magnetic field, where does that come from, guys? What color is magnetic field? Any ideas?
Like North Pole or South Pole, maybe?
Okay, so I'll give you 2 points for that one. Where do we get the Earth's magnetic field from?
The liquid iron moving in different directions.
Okay, Matthew, explain. Where'd you get that idea from?
I think I've just heard it before. Is the way that the iron flows and the way it's polarized kind of generates the field.
Okay, I'm gonna give you 5 points for that one. All right. Earth's magnetic field, how does it protect us from space radiation? What do you suppose would have happened if the Earth did not have its magnetic field? Any ideas?
We'd be scrambled like an egg.
Okay, Lucas, why did you say that?
Well, because all the solar radiation that we'd be getting would just literally cook us instantaneously.
Okay, so what do you mean by the solar radiation?
So, the sun obviously puts off different wavelengths of, electromagnetic radiation. It's not just light. It puts off heat and gamma rays and all that other fun stuff. It just loves to just destroy living cells. So we'd kind of be scrambled like eggs if that magnetic field wasn't deflecting a lot of that stuff back into space.
Okay, Lucas, I'm gonna give you 5 points for. So, how does the magnetic field deflect radiation, space radiation?
I'm lost on that one, I'll admit.
No, I mean, I'm not talking to you in general. If anybody wants to jump in at this point, what do you guys think? Okay, so a couple of questions. Number one, Earth's magnetic field. What's causing it? What's the worst that can happen if we didn't have the Earth's magnetic field? Obviously, it protects us from space radiation. So the next question is, what kind of radiation? A lot of what you have in your backgrounds come from your exposure to whatever it is that you were exposed to at school, which is usually nothing so far, or through the movies and the shows on TV. Case in point, most of you guys probably seen this movie, The Core. Okay, I noticed that a lot of you guys get your insights from The Core.
It was a secret government program.
All right, so those of you guys have seen it, just give yourselves 5 points.
Known as Project Destiny.
We're building a weapon that could generate targeted seismic events.
Designed to use
All right, so what's the premise of the movie?
earthquakes to attack our
Evidently, the core stops spinning at some point, for whatever reason. As soon as the core stops spinning, all of a sudden the magnetism completely vanishes.
enemies.
I'm getting a seismic reading.
It was a perfect, untraceable weapon.
So now they have to get a bunch of heroes to get down to the core and then jumpstart the core again. So it needs to start spinning.
10 years ago.
Until something went wrong.
So that's the premise of the movie. And now they're trying to portray what it would look like if it didn't have the Earth's magnetic field. If the Earth didn't have a magnetic field,
Left the superstorm. Popping
they're talking about the electrical
up all
superstorm.
over the world. I'll put this as simply as I can. Everybody on Earth is dead in a year. The core of
Okay, Lucas, I think you're getting a lot of your stuff from here.
the Earth has stopped spinning. The spinning core protects us from cosmic radiation. Without it, radiation will create superstorms. Microwaves will literally cook our planet.
How could this have happened?
It was Project Destiny. We killed a planet. So, how do we fix it? We can't. The core's the size of Mars. You're talking about jump-starting a planet.
What if we could?
We're here about your legendary ship.
What would it take to get it in 3 months? $50 billion. Can you take a check?
We need you to control the flow of information.
You want me to hack the planet? I'm gonna need Star Trek tapes and Hot Pockets.
You are good. Is there anything you can't do?
Not that I'm aware of.
You're trying to save the world. It's impossible. I came here to save my wife and children. I just hope I'm brave enough to save 3.
I can't wait to get into an untested ship, go to the center of the Earth, and restart its core with 1,000 megatons of nuclear weapons. Then we outrun the biggest shockwave in history.
Hot damn.
San Francisco is in ruins.
The whole West Coast is out. And it's decaying faster than we thought.
2, 1.
Going in.
Whoever goes into the core is not coming back. We're losing oxygen! Breach! We got a job to do. Let's do it.
Oddly enough, I've never seen that movie, but now I want to.
I'm very surprised you haven't, because I was 100% sure that you were getting your ideas from this movie.
No, I was. I actually have never seen it, but it's like there's actually some big names attached to it.
Oh, at the time they made the movie, most of these people weren't that famous. Now they are. This is like 20 years ago, maybe more than 20 years ago. How many of you guys seen this movie? Anybody? Not a single person? All right, so that's kind of sad. All right, moving forward. I think I don't know why we got stuck in there, but all right, so the core.
Could it be true?
Oh, this stuff is becoming somewhat outdated, so I think I have to get my PowerPoints up to date a little bit.
Small magnetic clasp erasing bank details? How hard is it to wipe out a credit card anyway?
All right, how hard is it to wipe out a credit card? Is it easy or is it hard? I'm talking about just using household magnets. What do you guys think?
Pretty hard.
Okay, you would think it's pretty hard? Or is it pretty easy? I mean, have you ever tried to wipe out somebody's credit card? I'm talking about ex-girlfriend, boyfriend, your mom, your sibling, somebody pisses you off by using a simple household magnet. What do you guys think? Hard, or do you think it's fairly easy? We'll find out.
Superman the Escape blasted off into extreme ride history. Burning rays for its maximum velocity. Towering ascent.
So the magnetic levitation we kind of get. But how does the magnetic propulsion work?
Seemingly endless airtime.
Foreshadow the future of roller coasters, or at least the future of the high end of roller coasters. The very technology intense, extreme experience that a roller coaster can give its riders.
Speaking of the magnetic propulsion.
This could be a caterpillar. Oh, what?
Okay, guys, this is a really good movie. It's The Hunt for Red October. If you haven't seen it, I'd strongly recommend it. This movie is like 20, 25 years old, but it's still a really good movie.
Caterpillar drive. Magneto-hydrodynamic propulsion. You follow? No. It's like a jet engine for the water. Goes in the front, gets squirted out the back. Only it's got no moving parts, so it's very, very quiet. Like how quiet? It's doubtful our son would even pick it up.
All right, so this is based upon a book, which was supposedly based upon a real event, and then later it turned into a novel, and the movie is based upon that novel. So the Russians got this technology, which is based upon something that they have, top secret project, magneto hydrodynamic propulsion unit that they have. So when it kicks in, this is a magnetic propulsion unit. You become sonar invisible, so it generates no sound whatsoever. Okay, at the time of the making of the movie, this was top secret. All right, the United States has this technology now, and today, obviously, this is science fact. The technology is already here. It's top secret, but the physics of it is easy enough so that we could actually discuss it at the community college level. Engineering of it is almost next to impossible to pull off, and somehow they were able to do that. So you will understand the physics of it just fine. At the same time, you will understand the engineering problems that it's got, that somehow they were able to solve. All right, so as soon as the technology kicks in, it's got no moving parts. All right, so you don't have an engine that makes sound, so it becomes sonar invisible.
What happened?
Sonar contact, Captain. Fourth quarter. Close aboard. American, Los Angeles class.
American, Captain.
Course 310.
Is the American turning to follow us?
No, Captain. The American is continuing in his original course. He's continuing northwest.
He can't hear us.
All right, so let's talk about magnetism. Okay, so whenever you have a magnet, notice that it's going to have two poles. One pole is known as the North Pole. The other pole is known as the South Pole. Where do we get this naming convention from, nomenclature from? Why do we call one end the North Pole, the other end the South Pole? Does anybody know? If you know, just jump in at this point. This is more of a knowledge question.
Because of compasses. That's
okay. Explain. It's exactly right. So what's a compass? No. I'll give you 5 points for that one, guys. What's a compass? Compass is a magnet and a pivot, right? So when you let it go, what happens? One end is always going to point towards the North Pole. Okay, which is true. What's true for a compass is also true for every single magnet. If you suspend a magnet just using a single string, a couple of strings, I don't care, it's always going to orient itself on the direction of the Earth's magnetic field. End pointing towards the North Pole is known as the North Pole of a magnet. The end pointing towards the South Pole becomes the South Pole of a magnet. So that's where we get the naming convention from. Speaking of a compass, it's a magnet on a pivot. By using a compass, you can actually map the magnetic field lines. All right, so you got this magnet, and this is the compass that you're using. And notice that you can just map these magnetic field lines clearly. And now I want you to notice that the magnetic field lines start at the North Pole of a magnet, and they point towards the South Pole of a magnet. All right, so here's a magnet. Here's the North Pole of a magnet. Here's the South Pole of a magnet. So you can map the magnetic field lines. So they will start at its North Pole, and they will end at the South Pole of a magnet. I'm not entirely sure why we use the letter B to denote the strength of the magnetic field instead of M. M is used for magnetization usually. All right, so this is going to represent the magnetic field strength. The proper unit is T. T stands for Tesla. More about Tesla later in one of the future lectures. In the United States, we use Gauss. In physics, we use Tesla. So that's the strength of the magnetic field is going to be denoted using the letter E. All right, guys, unmute yourself if you have to say something. Earth's magnetic field is kind of a bit of a mystery there because the Earth is magnetized, and magically the Earth's magnetic field points towards the North Pole. All right, so it's going to look like this, as if it's created by an invisible magnet inside the Earth, whose North Pole is coincident with the South Pole of our geography. All right, so what's responsible for the magnetic field is this invisible magnet inside. So the question is, what is this invisible magnet? And how is the Earth's magnetic field generated? Furthermore, how does the Earth's magnetic field protect us from these charged particles? Something interesting about magnetism, magnets are obviously magnetized, and iron is very easily magnetizable. Okay, so we talked about the Earth's magnetic field. If you take a magnet, if you break it into smaller and smaller pieces, it doesn't matter how small the pieces are, every single piece is still going to be magnetized. So what is the magnetic charge? Electrical charge, it could be positive or negative. So where do we get magnetism from? What causes magnetism? All right, because just breaking a magnet into smaller and smaller pieces gives you no information whatsoever. The only thing you end up doing is you end up getting smaller pieces, and every single piece that you get, it doesn't matter how small the pieces are, every single piece is still going to be magnetized. So what is the origin of magnetism? Where do we get magnetism from? Do we have any magnetic charges, like a North Pole of a charge or a South Pole of a charge, otherwise known as monopoles? This stuff that we understand, the light poles will